Michio Kaku, a theoretical physicist at City College of New York, is fascinated with the big questions in science, like whether the laws of physics require that all living things die.
One of the iron laws of physics is the second law of thermodynamics, which says that everything rusts, everything decays, falls apart. We're all made out of atoms, and these atoms in turn obey the second law of thermodynamics.
Anything and everything in the universe has the tendency to go from order to disorder. And once the damage is done, it's extremely difficult to reverse things and unmix them. It's a process known as entropy.
If I mix coffee, I realize that when I put cream into coffee, I increase entropy, I increase disorder. In fact, to see this milk jump out and reform in this cup is such a preposterous event that you would have to wait longer than the lifetime of the universe to see it happen.
The second law of thermodynamics is an unremitting force. Nothing is immune to the power of entropy, not even the cells in our body.
We'll start with understanding what big numbers look like, and we're going to keep this very simple. And we're going to use some scientific notation in here to shorten things up. For example, 10 is really 10 raised to the first power, or 1 followed by 1 0. 100 is 10 raised to the second power, or 1 followed by 2 zeros. 1,000 is 10 raised to the third power, or 1 followed by 3 zeros. Are we seeing the progression here? Now let's go up to a million. A million is 10 raised to the sixth power, or 1 followed by 6 zeros. A billion is 10 raised to the ninth power, or 1 followed by 9 zeros. And likely a trillion, 10 raised to the 12th power. A quadrillion, 10 raised to the 15th power. And a quintillion, 10 raised to the 18th power, or 1 followed by 18 zeros. That's an example of some very large numbers, and we'll be dealing with these. In other words, the probability of getting 100 left-handed amino acids together to form a small biological protein is 10 to the 30th power, and again, that is 1 followed by 30 zeros. I'm going to ask you a question. How believable is that? In other words, what's your credulity factor there? How credible is that claim that it happened by random chance? But wait, there's more. This number 10 to the 30th only measures the probability of getting left-handed amino acids. Did you know order also matters? Yes, it does. We just can't get amino acids for a protein. We have to get the right amino acids. We have to get them in the right order. For example, let's talk about order here. A jumbo jet, a Boeing 747, contains about 6 million non-flying parts. Not one single part of that Boeing 747 flies by itself. So what makes it fly? It's called design and order. I don't think anybody would say random chance. It's design and order. Likewise, a cell is made up of billions of non-living parts. So what makes it alive? Well, the obvious answer is design and order. So in building our biological protein of 100 amino acids, number one, they have to be all left-handed, and they have to be in the right order. In other words, amino acid number 1 has to be first in the correct order. Amino acid 2 has to be in the correct order. Amino acid 3 has to be in the correct order, all the way up to number 100. Now, I want to add something in here, commonly called the law of large numbers. Mathematician Emil Borel proposed 1 chance in 10 to the 50th as an upper limit that a chance at event would occur. In other words, 1 followed by 50 zeros. He said that's an upper limit. If beyond that, it's not going to happen. Well, there's still always a possibility. It's never quite zero. But to believe it could happen beyond that, folks, is not science. It's faith, because no one's, as far as we know, has ever observed anything beyond that limit to occur. So this presents an even bigger problem now for the evolutionists. You see, again, there's hundreds of different types of amino acids, but only 20 used in life. To make it even easier for the evolutionists, what we're going to do is a little experiment. We're going to make it easy for the evolutionists. We're only going to start with and use the 20 used in life. All those amino acids, all those other hundreds of amino acids, we're not even going to bring into this experiment. We're only going to include the 20 that are used in life. So we're going to make it very simple for the evolutionists. So what we're going to do is fill a paper bag with all these amino acids, just the 20 different kinds used in life. And we're going to have multiple copies of each one. In other words, of amino acid 1, we're going to have 1,000 copies. Of amino acid 2, we're going to have 1,000 copies. Amino acid 3, we're going to have 1,000 copies. So there's an equal amount of each of the 20 different kinds of amino acids inside that paper bag. And our challenge is, number one, to blindfold ourselves, then reach into that paper bag and pull out the correct amino acid in the correct order until we get a biological protein consisting of 100 amino acids. Let's see how this would work. To get the very first amino acid in the correct order, it would be 1 chance in 20. Not too bad. We got 1. But to get the first 2 amino acids, the correct ones, in the correct order, would be 1 over 20 times 1 over 20, or 1 chance in 400, just to get the first 2. How about the first 3? Now, again, they have to be the correct amino acid in the correct order. Just to get the first 3 that way, would be 1 over 20 times 1 over 20 times 1 over 20, which would be 1 chance in 8,000. Now, how about to get all 100 amino acids, the correct amino acid in the correct order? Well, that would be 1 over 20 times itself 100 times, or 20 to the 100th power, which equates to 10 to the 130th power. And folks, that is a very large number. That is a number that looks like this: 1 followed by 130 zeros, well beyond the law of large numbers. Where's our credulity factor now on this? Well, to help us illustrate how big that number is, let's suppose we just took 10 to the 21st silver dollars, just 10 to the 21st silver dollars, and covered the entire United States with them. That would cover the entire United States to a depth of 120 feet. And that's only 10 to the 21st silver dollars. Our probability of getting that protein, small protein, is 10 to the 130th power. Far beyond the law of large numbers. Again, I'll ask, where's your credulity factor now? But wait, there's still more in this. We've just talked about one protein. In the simplest type of life we know of, it takes about 387 proteins. The probability of getting 387 proteins is 10 to the 5,000th power. That's 1 followed by 5,000 zeros just to get 387 proteins, the simplest form of life we know of. And that doesn't account for all the other components inside there, such as DNA and RNA and all the other more difficult components to get. Are you starting to see? The whole idea of evolution is not science.
Life from non-living matter. And this illustration often used is the one of the monkeys at the typewriter. Okay, so we have a monkey sitting at a typewriter, and the claim here is basically if you leave chance and time long enough, you will get life. Don't worry about it. Yes, it's strange, yes, it's wonderful, but leave enough matter, 600 million years on Earth, and you will have life. So the monkey's sitting at the typewriter, and the chances are eventually he produces the complete works of Shakespeare, so what's the problem? So there's no problem, there isn't an issue, right? You just leave him long enough, you'll be fine. And at 1 keystroke a second, the monkey might well eventually get to the complete works of Shakespeare, but he doesn't manage to do it in 600 million years. So what I decided to do to run the numbers is instead of saying type the complete works of Shakespeare, I just ran the numbers for how long would it take a monkey typing at 1 keystroke a second to type to be or not to be, that is the question, right? On average, how long is it going to take my monkey friend in one keystroke a second? I don't know how long you think that would be. Maybe you could have a guess. Would it be less or more than 600 million years, which is the period life on Earth is supposed to have emerged within? And when I ran the numbers, to be or not to be, that is the question, takes 12.6 trillion years to type just that phrase. And a DNA string, which you have to have for like the life we have now, doesn't emerge it's not like a sentence's worth of information. A DNA string has got as much information as the Encyclopedia Britannica. Right? So if we're saying that emerged, something of that complexity emerged by chance, undirected, within 600 million years, again, it's mathematically possible, but it's so incredibly unlikely that it would.
This has been pointed out by Frank Tipler and John Barrow in their book, The Anthropic Cosmological Principle. They list 10 steps in the evolution of Homo sapiens, each of which is so improbable that before it would have occurred by chance alone, the sun would have ceased to be a main sequence star and incinerated the Earth. They estimate the evolution of the human genome, the odds of this are somewhere between 4 to the negative 180th power to the 110,000th power, and 4 to the negative 360th power to the 110,000th power. So if evolution did occur, it would literally be a miracle, and therefore evidence for the existence of God.
Chance cannot do anything because chance is not anything. And when you say to me that the universe was created by chance, you are saying the universe was created by nothing. It's the rabbit out of the hat. Without a hat. Without a rabbit. Without a magician. If this mythology were not taken so seriously today, we could be amused by it. But what's at stake is not just theology, but science itself.